Okay, so we are now working on our next topic, that is the topic 4.3, that is about the factor and the remainder theorem. Those two theorems, they work in some results about when you perform synthetic division or sometimes long divisions with polynomials divided by binomials. So the result, we apply it when using synthetic division, but synthetic division is only used when you divide polynomial by binomial. But you can use synthetic division, and some of you, synthetic division may not be new. We will practice on that. But it's two theorems that we're going to keep the focus on: the factor theorem and the remainder theorem. So what are these theorems? So we have the factor theorem. It says if x minus r is the root, it's like the one of the roots of a polynomial, or zero, r being a zero for the polynomial, and if x minus r is a factor of a polynomial function, or just a polynomial p of x, then p of r equals 0. So if you can be a factor, then if x minus r is a factor, when you plug in r, then it's going to make the polynomial equal 0. X minus r is a factor, then p of r equals 0. And the second theorem is the remainder theorem. It says if a polynomial p of x is divided by the binomial, is divided by x minus r, then the remainder of this division is equal to p of r, So these are the two theorems that we will be practicing over in this section. So let's practice a little bit about on synthetic division. Now, when solving synthetic division, we first, when performing synthetic division, we first need to set up the problem. So however the problem is presented, you must first identify your dividend and the divisor. After doing so, you need to keep your dividend in descending order of exponent, from the highest to the lowest. So first, I'm gonna try to keep this as negative 5x to the third minus 20x squared minus 11x plus 17 over x minus 3 plus 3. So that's the first thing I do. I reorganize my terms, and then make sure that the dividend is written in the order of exponent, descending order of exponent. And then the next thing I do is I set up the division, like like this setup right here. And then inside of this little box that I have here, I'm going to put the value that makes the divisor equal 0. Or you can even set the divisor equal 0. So x plus 2 equal 3 plus 3 equals 0 means x equals -3, and -3 is what I put inside of the box right here. Next in my setup, I'm gonna try to get all the coefficients, to list all the coefficients of my dividend in the next to this number in the box. So list all the coefficient, -5, -20 with their sign up, obviously, -11, and then 17. So I list my coefficients of the polynomial. Then start by dropping the first coefficient, dropping it below the line, underneath of the line, -5. And then we multiply it by the outside number. -5 times -3 is +15. Write it underneath of the next coefficient, the coefficient next to the one you dropped above the line. So that's 15 underneath of 20, but above the line. Well, we will add them. We will add them or combine them to get the result that will go underneath of the line. So we get -20 plus 15 is another -5. We will do the same thing that we did with the first -5, which we multiplied by -3. It's another +15 again. And we do the same thing that we did with the first +15. This time it's -20, -11 plus 15. That is +4. And then that's the next number here that I put underneath of the line will multiply -3. That's -12. That it will be combined with the 17 that is +5. Now, if the top polynomial is, if I would call P of X equals the top expression, this remainder, that's my remainder. And according to the remainder theorem, I could tell that P of this number in the box, P of -3, is the remainder that's -5. That's +5. So that's what the remainder theorem is saying. So if when you divide x minus r being -3, you get a number that is the remainder, and this is the output of this value in the box, or when you set x minus r equals 0, if P of this value is equal to the remainder. Well, I just explained what the theorem was, but this is not what we're doing here because they just asked me to write the answer in the format of quotient plus remainder over divisor. We already have the divisor, that's our divisor here. The quotient, it will be, those are going to be the coefficient of your quotient. of the quotient those are the coefficients of the quotient. Now, the quotient is going how to find the power of the quotient. So we divided a polynomial of degree 3 by polynomial of degree 1 to get the power, the highest degree of the quotient is to subtract the highest degree, the degree of the dividend. So we're gonna say that the degree of the quotient is degree of dividend minus degree of divisor. In this case, it's 3 minus 1 equals 2. So that will give you x, negative 5x squared minus 5x plus 4. That's your quotient. So quotient here is negative 5x squared minus 5x plus 4. And then the remainder is the top. That was 5. And over the divisor, that is what was in the denominator of your function of your division, x plus 3. So that is the result of your synthetic division. First, you rearrange the term of the dividend. Next, you set it up with the bar and the box. Inside of the box is the value that makes the denominator equal 0. In this case, it's negative 3 because you set x minus x plus 3 equals 0. When you solve it, x equals negative 3. You put that negative 3 in the box, and then you drop down the first coefficient, multiply by the element in the box, and continue the process, and then write your solution as quotient plus remainder over divisor. And the degree of your quotient will always be the subtraction of the degree of the dividend and the degree of the divisor. And then you write your quotient. The numbers found in the synthetic divisions are going to be in the same order that you, in descending order, the coefficient of your quotient. Let's see the next example. In the next example, that's where we're gonna apply the theorems that we talked about, mostly the factor theorem. The factor theorem. So the question here that we need to answer is to perform a synthetic division to verify if x equals negative 3, negative 1/3, and x equals positive 1/3 are zeros of this polynomial function. They said use the synthetic division. Now to do so, this is the synthetic division we have. Now we're going to set up for the first one. negative 1/3 in the box, and the coefficients are negative 108, 432, 555, 520, 52, negative 48, and negative 60. We're going to perform this synthetic division. First thing is to drop the first coefficient, negative 108. Negative 108, it's like you dividing 108 by 3. Negative 108 divided by, multiply by, we should multiply this, right? So that's negative 108 divided by 3, negative 3, which would be a positive number, is 36. So 36 plus 432. 36 plus 432. That is 468. 468. We multiply it by negative 1/3, the number in the box. So it's like dividing by negative 3. So 468 divided by 3 it's negative divided by negative 3. So it's negative 156. Now, negative 156 plus 552. That is positive 396. Positive 396 minus 48. Is 348. Oh, wait. So there's a problem here. That should have been here. So negative 156 minus negative 156 plus 552 is 396. We're gonna multiply 396 by we're going to multiply 396 by negative 1/3, which means dividing by negative 3. 396 divided by negative 3 is negative 132. That we negative 132 minus negative 8 minus 48 minus 48 is negative 108. I mean 180. We multiply it by 1/3, negative 1/3, which is dividing by negative 3, negative 3. So that's negative, that's positive 60. And then that is 0. Now this 0 that we get for the remainder, it goes to the fact that we know the theorem. It says that if if you have the division of x of a polynomial by x minus r being negative 1/3, then p of r is 0. That means p of -3 equals 0. Thus, oh, the remainder equals 0. I gotta put this. Remainder is 0. Thus, you know that p of -1/3 is 0, meaning -1/3 is a 0, or root of p, the polynomial p. Now let's try the same thing for the next value. Now let's for x equals 1/3, we're gonna see if the synthetic division will end up being also 0, or if it's different. If it's 0, then 1/3 will be a 0 of the polynomial function. If it's not 0, if the remainder is 0, the the 1/3 is a 0 of the polynomial. If it's not 0, then it will not be a 0 of the polynomial. So let's wrap the first number, -1 away. We divide it by 1/3. So -108, 108 divided by -3. -108 divided by +3 is 36. -36. -36 plus 4, 32. Is 396 times 1/3. That's 132 plus 552. That is 684 times 1/3. That's 228 plus minus 48. That's 180 divided by 3, 60. And then that is also 0. So we have the same conclusion as we had for 1/3, -1/3. So 1/3 is a 0 for the polynomial function. Now, given that we have these results, that the remainders both of the synthetic divisions are 0, it means that from both of the zeros we can get a factor of the polynomial. So the first one, when we had -1/3, we had a 0. That means x plus 1/3 is a factor. Remember, if r is a 0, according to according to the factor theorem, if P of 0 equals 0 or R is 0, if R is a 0, then X minus R is a factor of the polynomial. So basically, when you have the zero, when you find the 0, you find two things. You find one, the a value that makes the polynomial equal 0 when you plug it in. Also, you find a factor if you want to factor that polynomial. So that's why here I make the conclusion that we have a factor that is x plus 1/3. Now, I did the division separately here and here, but if I want, and it's more it's more efficient when you use the result of one to do the other one, because it helps you if you want to factor your polynomial. So that's why I'm going to perform the division for 1/3 with the results I had for the division for negative 1/3 to, and I know already that 1/3 is a factor, but I just want to find the remainder trinomial that will be factored with both of these factors. So let's perform the division with the result of the division for negative 1/3 with the result of the division of 1/3. So we're gonna drop the negative 108 here, and then we will multiply by 1/3. So that's negative 108 divided by 3. That's negative 36 plus negative 36 plus 68 plus 468. That is 432. We will multiply by 1/3. That is 144. We add it with 396. We add with 396. That is 540. We multiply by 1/3. That is 180. And then that is 0. Okay. Now with this result, we know that we also have another factor. So that means we have two factors. So basically, remember, you had a polynomial of degree 4. We already have one factor of degree 1, another factor of degree 1. So the other trinomial that's left, which are the coefficients here, will be of degree 2, right? So basically, here is the factored form of the equation that they asked me to solve right here, right? So we're going to write it as x plus 1/3 times x minus 1/3 times this trinomial, negative 108x squared, plus 432x plus 540 equals 0. So we already have this. We just have to solve negative 108 x squared plus 432x plus 540 equals 0. So we already have the two zeros already, because we realized that we proved that negative 1/3 was a zero, and positive 1/3 was also a zero. Now we're gonna solve this equation to find more zeros, if any, and that will be all of them together will be the solution of this equation. So we can divide everything by -108. It's divided by -108. Every term by -108. So we have the first one is x squared minus 432 divided by 108. By -108 is negative 4x minus 540 divided by 108 is 5 and equals 0. So then we can factor this as x plus 1 times x minus 5, that equals 0. So we get two factors, x plus 1 equals 0, or x minus 5 equals 0. X equals -1, x equals +5. So all the zeros are -1/3, +1/3, -1, and +5. So this is the list of the zeros of this polynomial of degree 4. So they ask me to find the zeros. So -1/3, +1/3, -1, and 5. So in this next example, we're going to perform the synthetic division. They say use the synthetic division to evaluate this division, and write x squared plus 8x squared minus x to the third plus 8x squared minus 5x minus 72 in the form x cubed plus 8x squared minus 9x minus 72 equals divisor times quotient plus remainder. Well, you should notice that sometimes the remainder is 0. So if it's 0, then you're not going to put anything, or you can just put a 0 at the end here, or you don't even need that part, because if it's 0, then there's no need for this part. So let's go ahead and set up the synthetic division. Well, you're going to have your -3, because the bottom, you need to set it equal 0. So let's go ahead and set the denominator equal 0 to find the box. So I'm going to set it up. So here we need to have the denominator x minus +3 equals 0. Subtract 3 on both sides. X equals -3. So that is your -3 right here. And then we're going to make sure the terms are in decreasing order of exponent. It's already in this format. We can just list the coefficient 1, 8, -9, and -72. Drop the first one, 1. 1 times -3 is -3. We add 8 and -3, that's 5. 5 times -3, that's -15. Negative 15, negative 9 is negative 24. Negative 24 times negative 3 is positive 72. So the remainder is 0. And the degree of the quotient, so quotient here, with the degree being 1 minus 3, 2. So that's going to be x squared plus 5x minus 24. That's a quotient. So we can write it as divisor times quotient plus remainder. So divisor was x plus 3. We have the quotient that is x squared plus 5x negative minus 24, and the remainder that is 0. So x cubed plus 8x minus 9, 8x squared minus 9x minus 72 over x plus 3 is x, well, that's this, we need to write this equals divisor that is x plus 3 times quotient that is x squared plus 5x minus 24 plus quotient that is 0, but remainder that is 0. So that's the answer here. So that is the answer they wanted me to write in this format. So if we want to place them in here, we can have that's x plus 3, x squared plus 5x minus 24. And then the remainder, 24, the remainder is 0, so we don't need that part. The question is, use the above result to determine if x plus 3 is a factor of x squared, x cubed plus 8x squared minus 9x minus 72. Well, the answer here is because the remainder is 0, the answer is yes. X plus 3 is a factor of x squared plus 8x cubed plus 8x squared minus 9x minus 72. The answer is yes. I do have a few more problems that I want to go over with you. The first one is when you have missing terms. Well, remember the first problem we did, I urge you to make sure that you keep your terms of the dividend in order, in descending order of exponent. But also you have to make sure that if there is any missing term in your problem, or mostly the top expression, you must make sure you replace the missing terms by 0. So that said, if this is the problem we're solving, the first move that we need to make is to rearrange the terms and remember to keep any missing term as 0 before you replace the coefficient as 0 if they're not there. Like if there is a degree that's not there. Imagine here the highest degree here is 5. So you don't see the degree 4, you need to replace it by a 0. You don't see the degree 3, you need to replace it by 0. And you don't see the degree 1, you need also to replace it by 0, which means the problem should have been written as, the denominator is fine, x minus 2, but that's an x to the 5th plus 0x4 plus 0x3 minus 2x squared plus 0x plus 1. That's what we should have seen. But because the other ones were 0, that's why we didn't see them. But before you place them in the form to perform your synthetic division, you must make sure that you have your terms identified. So let me set up now. Let me have my setup. When we set this equals 0, that's x minus 2 equals 0. So we add 2 on both sides. So that will give you x equals 2. So 2 goes in the box. Now we're going to set up with the coefficient. We start with 1. Start with 1. The next one is 0. After that, there is another 0. There is a -2, a 0, and a 1. So these are all the coefficients that we want to work with. So drop the first one times 2. That is, it's a 2 here. Times 2, that's 2. 2 here, 4. 4 times 2, 8. 4 times 2, 8. 8 minus 2, 6. Oh, wait. We need to put 4 here. 4 times 2, 8. 8 minus 2, 6. 6 times 2, 12. 12 times 2, 24. Well, that's 12 here. Times 2, 24. And 24 plus 1, 25 is the remainder. We were dividing a degree 5 and a degree by a degree 1. So the result will be a degree 4, the quotient. So that's x4 plus 2x third plus 4x 2 plus 6x plus 12. And if we want to write it in the format quotient, so that's your quotient here. We want to write it in the format quotient plus remainder over divisor. So that will be x squared, x to the 4th, sorry, plus 2x3 plus 4x2 plus 6x plus 12 plus 12 and then the remainder divided by the divisor, so plus 25 over x minus 2. So that would have been your answer. I wanted to solve this problem because sometimes when there are missing terms, we tend to think that this is the whole problem, but there are some hidden parts that you need to bring in before you perform your synthetic division. The next problem, it's similar to the last one we did when we were looking for the solutions, but sometimes they give you your solutions by showing you the graph of the function. So you have a few zeros, and you can be asked to find the solutions, but sometimes they give you just 1 0. Say for example, clearly here they give me all the zeros. That's x equals -3, x equals 3, and x equals 4. But let's imagine we didn't have all of them, so we can just pick them up here and then place them in the coordinate system. Present your solution. So here's what I'm trying to say here. They give me the function f of x equals 1 over 6 x to the third minus 4x squared minus 9x plus 36. They say is the given if the given below. The graph is given below. So they say use the graph to solve the equation. So basically they're telling you to find the zeros of the function. Well, the zeros of the function is where the graph crosses the x-axis. So that's why your solutions of this equation will be -3, 2, 3, and 4. But sometimes they only give you some of the solutions. They don't give you all of them, and they ask you to find. Say, for example, they only gave you 1 0. They only gave you this portion of the graph. And they ask you to find the remaining zeros. To solve, they could do that. Huh? They could give you that. And then say, solve this equation. Solve this equation. So what would you do here is you would perform your synthetic division, right? You have a polynomial degree 3. If you perform the synthetic division, so that means we know that -3 is a 0. So you would know that if -3 is a 0, x plus 3 is a factor, then you would perform the division of x cubed minus 4x squared minus 9x plus 36 by x plus 3. So we would set up, that's -3 here, that's 1, -4, -9, 36. We drop the first one, multiply by -3, that's -3. So that's -7, positive 21, positive 21. So 21 minus 9 is positive 12. That is -36, 0. So that means you're gonna have x plus 3, that is a factor because the remainder is 0, times this polynomial, that's 3 minus 1. It's a polynomial of degree 2. So x squared minus 7x plus 12. We're solving this equation equals 0. Now we have it in factored form. We already know from this one, x equals -3. And this one will be x squared minus 7x plus 12 equals 0. This is a quadratic function equation. Now we can find two factors of 12 that add up to -12, -7. So that's -4 and -3. So we factor this as x minus 4, x minus 3 equals 0. We got x minus 4 equals 0, or x minus 3 equals 0. And then finally, x equals 4, x equals 3. So we have all the zeros of the polynomial. So what I'm showing you here, in some problems, they can give you all the zeros on the graph, but they can give you just one and ask you to find the other one. Or they can give you 2 and ask you to find the third one or the fourth one. So that's what you need to be prepared for on your homework and potentially on your test.